Hey everyone, Joe here, and today I'm going to be showing you how to hook up an LED. It's pretty easy to do, requires very little math, and if I could do it, I'm sure you guys can do it too. So let's get started. To get an LED to light up, you're going to need a voltage source, a resistor, and the LED itself. The resistor in this circuit helps to limit the voltage and the current to the LED. Every LED has its own voltage and current rating. If you exceed those, the LED will just blow up. If you don't exceed them, it just won't light up at all, or maybe barely light up. When the circuit is operating, the source voltage will be the same up into the resistor. The resistor will step down the voltage to the proper rating of the LED, and at the same time, it'll limit the current going through the entire circuit. Here I made the circuit a little more understandable. I labeled the voltage source as Vs, I labeled the resistor as R, the current going through the LED as IF, or the forward current, and the voltage across the LED as VF, or the forward voltage. The first thing you got to figure out is what the operating voltage is and the operating current is of the LED. This information can be found in the datasheet. The datasheet will call these the forward voltage and the forward current. If you don't have the datasheet to your LED, I have provided a table in the description giving you typical values for the voltage and the current based upon the LED's color. If you don't know the LED's color, just start with the color that has the lowest operating voltage so you don't blow up your LED. The next thing you do is to figure out how much voltage your source needs to provide. You do this by picking a voltage source that is higher than the applied voltage of the LED. And the last thing we gotta do is to pick what value our resistor has to be in order to properly protect our LED. This is gonna need some math. The first equation you need will actually calculate the value of the resistor, and that's going to be the voltage source minus the forward voltage of the LED, all divided by the currents necessary to light up the LED. The next thing we have to do to pick a resistor is to calculate its power rating. The power rating is how much energy is being used by the resistor over time. In this case, it's converting some of the electrical energy to heat in order to protect this LED from blowing up. We can calculate this by the power of the resistor is equal to the current going through the resistor squared, and in this case, the current going through it is the same as the LED's current. We take that and we multiply it by the resistor's value. Once this is calculated, we pick a resistor that has a power rating of about 2 times to be safe. And that's really it. Let's take what we learned and actually light an LED up. Here I have a white LED, and if you look, the two leads have different lengths. And if I get the zoom in right, you can see that there's this little piece of metal in here. If you look close enough, there's a smaller one and a bigger one. The smaller piece denotes this as the anode, and this is denoted as the cathode. You could also tell what's anode and cathode by the longer lead and the shorter lead. Longer lead is the anode, shorter is the cathode. And one last way you can check is to see the case itself. It's flat on the cathode side. In our schematic, the anode is this side of the symbol and the cathode is this side. I don't have the data sheet of this LED, but I do know that it's white, and I can actually use the typical values for a white LED, which is 3.5 volts and 10 milliamps. Now that I have my forward voltage of the LED, I'm going to have to choose a voltage source. A common one to use is a 9-volt battery, and since 9 volts is greater than 3.5 volts, this will be perfect for this circuit. And the last thing we gotta do is figure out the resistance value and its power rating. We do that by using this formula first. We have 9 minus 3.5 divided by 0.01. That's the source voltage minus the forward voltage of the LED divided by the forward current of the LED, and I get 550 ohms. Thing is though, I don't have 550 ohms in stock, but I do have a 1 kilo ohm. It's okay to go higher in resistance because that'll be less forward current and less forward voltage for the LED, so it won't blow up. Thing is though, it just won't light up as bright as you'd like it to be. So assuming that, calculating the power rating, we can do this formula here. It's 0.01 squared times 1000, that's that 1 kilo ohm resistor that we just calculated, and I get 0.1 watts. The resistor that I have is rated for 1/4 watt. So this is perfect. Now all we gotta do is hook up the battery, the resistor, and the LED just like in our circuit. And I'll be using these alligator clips to do that. And here it is wired up. Got the battery, the resistor, and the LED all in series. Just gonna make the last connection. And it works perfectly. This is a little dim. That's because I used a 1 kilo ohm resistor. Had I used a 550 ohm, it'd be a bit brighter. And had I assumed 20 milliamps, it would still be much brighter. But I chose 10 milliamps to be on the safe side. Thank you so much for watching the video. If this helped you at all light up your LEDs at home easily, please consider giving the video a like. If you want to see more videos like this every week, consider subscribing to my channel. And if you have any questions at all, please leave them in the comments below.